Hi guys, in this video we're going to talk about density and how you calculate it. And to do this we're going to be using some Cornell paper, so let me get over to that. So here we go with our Cornell paper. Remember that you want to fill out your name, class period, and date, and our objective is density calculations. And we have two essential questions. What is density is the first one, and the second one is how is it calculated? So the first thing we need to do is talk about what density is. So let's go ahead and do that now. So density is a property of matter. It is just something that every object has, and it is the ratio of mass to volume. Now for density we use the letter D. D is for density. In math class, when you hear the word ratio, you should think a fraction. That's what a ratio is. And in science class, mass is an M and V is a volume. So the equation to find density looks exactly like this. Density is mass divided by volume. So when we're talking about density and density calculations, that is the equation that we're going to use. But to kind of understand a little bit more about what density means about an object, is we're going to use this definition. How close the particles are. So if I draw a couple of pictures here in some boxes, I'm going to use some particles. Let's see, we'll use some tiny ones. So if I draw some tiny particles here, wow, those are really small. And you can see that they're so small you can hardly see them, but I drew 6 there. And if I draw them a little bit farther apart, now I have something that is more dense. I'm sorry, less dense. Farther apart is less dense. So if I compare these here, we'll call this one A and this one B. At this point, A is more dense than B. So I've got my greater than on the A. A is more dense than B. Now if I draw another picture with some bigger particles, let's see what these look like. And I've tried to draw them in about the same spot as I did in B so that I can make a point here. When I look at these, because those particles are bigger, that means they have more mass, and so box C is also having a greater density than B. To compare A and C, we might need to know a little bit more about the particles and just exactly how close they are, but I'd have to guess that C is more than A just based on the size of those particles I drew. So we can talk about density from the terms, or from a particle diagram, which I think is a later objective, so we'll get to that. Okay, so density is how close particles are. Let's flip over to the back of our Cornell paper. Here it is, and let's do a couple of calculation examples and talk about how we're going to do the calculation. Okay, so here's our first example. If you need to take a minute and pause so you can write that example down, go right ahead and do that now. So I'm going to read it, and it says that the density of a piece of wood that has a mass, what is the density of a piece of wood that has a mass of 25.0 grams and a volume of 29.4 centimeters cubed? Okay, so I'm going to write on this a little bit. I'm going to underline what I need to know here. I need to know that the mass is 25 grams and the volume is 29.4 centimeters cubed, and it's asking me what is the density. So I'm going to start by writing down the formula, which is D equals M over V. This is a map that tells me where to put numbers. So D is what I'm looking for. I'm going to draw a little arrow here so I can have some room later. D is what I'm looking for, so I'm going to keep that. M stands for mass, and it tells me the mass is 25 grams. I'm going to go ahead and keep the G. V is for volume, and that's 29.4 centimeters cubed. And so now this is telling me to do some math. When you have a fraction like that, you're going to be dividing. So I'm going to take the numbers only, just the numbers. I'm going to kind of section these guys off here. They'll be used later. Don't be tempted to use that 3. So when I plug this into my calculator, 25 divided by 29.4, I get 0.85 and some other numbers, and I'm just going to stop there. I'm going to round to 2. The next number is a 0, which makes me want to leave it at a 5. And then I need a unit, and that unit is what I just circled there. Grams per centimeter cubed. I didn't cube anything, okay? This is the answer for my density.
So if you'd like to see more examples of calculating density, make sure that you ask your teacher. They'll be happy to go over some extra ones with you. And if you need any help, make sure you ask. You can learn how to solve for volume or mass in another video. Thanks for watching.